Which intermolecular forces exist in an aqueous hydrofluoric acid solution? Alright, so we're talking about intermolecular forces. First of all, what kind of intermolecular forces are there? We know, as we learned in class, there's ion dipole force that happens between ions and polar molecules. The electrostatic interaction between the charge of the ion and the permanent dipole of polar molecules, attractions, repulsions, that's ion dipole force. There's also dipole force that happens between polar molecules. The attraction, repulsion, the electrostatic interaction between the permanent dipoles of polar molecules. There's the London force, the London dispersion. This happens in between all molecules. We know this is caused by the electrostatic interaction between the instantaneous dipoles of polar and nonpolar molecules. And then, of course, there's hydrogen bond. This is a very specific kind of intermolecular force that only happens to certain molecules. You got to satisfy some conditions. There's got to be one of the three bonds: hydrogen fluorine bond, hydrogen oxygen bond, and hydrogen nitrogen bond. And also, you got to have lone pairs of electron on the very electronegative fluorine, oxygen, or nitrogen. And then these lone pairs will have electrostatic interaction with the almost stripped naked hydrogen proton. And alright, now that knowing all the four intermolecular forces that we talked about, let's look at our subject here. Aqueous hydrofluoric acid solution. What kind of intermolecular force do we have? Let's think about it. So first, we would have hydrogen fluoride molecule. Now, and it's an aqueous solution. Now, this is also hydrofluoric acid. Weak acid. You're going to have some dissociation, which means HF is going to be partially breaking down into hydrogen ion and fluoride ion. Some of it. The rest will stay in the molecular form. Well, you have ions. And hydrofluoric acid is, hydrogen fluoride is a polar molecule. So you will have ion dipole force. If it's pure hydrogen fluoride, then you wouldn't. But it's in aqueous solution, you got ions, there's ion dipole. And between these individual hydrogen fluoride molecules, since they're polar molecule, of course you're going to have dipole force. London dispersion force happens to everybody, so there's no need to say it exists everywhere. And then hydrogen bond. Do I have one of the three bonds? I got a hydrogen fluorine bound, and there's plenty of lone pair of electrons on fluorine in a hydrogen fluoride molecule. So yes, I would have hydrogen bond as well. So this aqueous hydrofluoric acid solution would have all four intermolecular forces existing in it. And that is the correct answer.